Hey guys, this is Mrs. Villette, and I've recorded this video to go back over the inverse trig functions mini quiz. And I'm in the math lab right now, so there could be some yelling or some background noise, so try to filter that out. So I'll start with this first one, inverse sine of root 2 over 2. Anytime you have an inverse trig function problem, what it's really asking for you to do is find an angle. So inverse sine is saying find an angle whose sine is root 2 over 2, which should be easy enough, except we have to pay attention to the angle restrictions for the range of these trig functions. So the correct answer for this is pi over 4. And the reason for that is that the inverse sine function outputs angles that are positive angles in the first quadrant and negative angles in the second quadrant. And what this problem is really asking you to do is to find an angle theta where the sine of that angle is the square root of 2 over 2. So I know that that corresponds to one of the 45-degree triangles, and that's going to correspond to the angle pi over 4. Now there is another place over here in the second quadrant where the sine is also root 2 over 2. That would be at 3 pi over 4, but that's outside of the restriction for the inverse sine function. Remember, these restrictions were created so that these functions would be 1 to 1, which would then create inverses. Okay, our next example, I'll go ahead and do all the sine ones so that we can be thinking about the same angle restriction the whole time, is asking me when is the sine negative 1/2. Well, here's when the sine is negative 1. Negative 1/2, remember sine is the y value, so I'm looking for a y coordinate of negative 1/2. If I dot that over and intersect the triangle and create a ray between those 2 points, I end up seeing that this is a 30, 60, 90 triangle. Now I could go all the way around to 330 or 11 pi over 6 to get there, but that's not what inverse functions say to do. So what I need to do is instead go there in the shortest distance possible. And the shortest distance possible is negative pi over 6, or negative 30 degrees. Okay, inverse sine of 1 is asking me for an angle whose sine value is 1. Remember, sine value is the y coordinate on the unit circle, and that would be right here, which would be pi over 2. So there may be many multiple answers that give you a sine of 1, like pi over 2, 5 pi over 2, 9 pi over 2, etc., but there's only one answer that is within the range restriction of the inverse sine function. We'll save the compositions for later, and let's go ahead and talk about the inverse cosine. So the inverse cosine is asking you for an angle. So when I see this, this is saying find me an angle theta where the cosine of that angle theta is negative root 2 over 2. But again, we're restricted to where we can look. We can only look in the first and second quadrants between 0 and pi. So negative root 2 over 2 automatically narrows me down to being in the second quadrant. And when I see a root 2 over 2, I know that that's one of my angles that is 45 degrees off of the x-axis. But the angle isn't itself 45 degrees. The angle is all the way from 0, which is 3 pi over 4, or 135 degrees. The next problem, I want an angle whose cosine is the square root of 3 over 2. Square root of 3 over 2 tells me that I have a 30, 60, 90 triangle. So a 30, 60, 90 triangle is going to have a short side of a half and a long side of root 3 over 2. Cosine is going to be the x coordinate, so I've actually drawn this triangle in the orientation that I want, with the cosine or the x value being root 3 over 2. And that angle that I've drawn is pi over 6. If I had asked you for the inverse cosine of 1/2, that would have been pi over 3, because that would have been the cosine value being 1/2, which would have been the same triangle but flipped up or flipped over the line y equals x. inverse cosine of -1 is asking me for an angle theta where the cosine of that angle theta is -1, but the theta has to be in the interval 0 to pi. So cosine is the x-coordinate. Where is the x-coordinate? -1, right here at pi. So my answer here is pi. Now that pi is on the very end of the possible range of angles that I could get. Okay, inverse tangent is very similar to inverse sine, except that I can't actually reach the end points of the quadrants. So I'm going to get negative angles in quadrant 4, positive angles in quadrant 1. Tangent is also telling you the slope of the terminal ray. So this problem is saying, give me an angle theta where the tangent of that angle theta is 0. In other words, where is the y over x equal to 0? But this angle theta has to be within the interval -pi/2 to pi/2, not including the endpoints. So we can clearly see that I'm going to get a slope of 0 when the angle is itself 0. 0 radians or 0 degrees. Now you cannot answer 2 pi. The reason you can't answer 2 pi is because 2 pi would cross over my boundary line and go all the way around, and I'm not allowed to do that. We're really thinking of this in terms of efficiency. So the most efficient thing is to stay in the first quadrant if you have a positive tangent and go backwards. So first quadrant if you have a positive tangent, but go backwards if you have a negative tangent. The inverse cotangent function is the only one that doesn't follow its reciprocal function, but we're not really going to quiz you on those functions. Okay, inverse tangent of 1 is saying where in the first or fourth quadrant is the tangent equal to 1. You should know this, that the tangent is 1 when the angle is a 45-degree angle, which is a radian measure of pi/4. So remember, this is saying the tangent of what angle is 1. In other words, where is the y/x equal to 1, but with the restriction that my theta needs to be here or here. And it can only be in one place because the tangent is either going to be positive or negative. Inverse tangent of square root of 3 is again saying, tell me an angle where the tangent of that angle is square root of 3, or the y over x is the square root of 3. Now hopefully you've recognized that you're going to get square roots of 3 if the ratio has the root 3 on the top so that the denominators cancel. So we want the y to be the bigger leg of the triangle of the 30, 60, 90. We want the x to be the smaller. And that should be when you have the 60-degree angle down at the base, or pi/3. So just a note on tangents, there's really only a few ratios that you get for tangent functions. Tangent is the ratio of the y to the x, which is also known as slope. And so if you draw this line at x equals 1, and then we draw off our tick marks for our unit circle angles, and I'm only going to do the right half because this corresponds with tangent. It's pretty clear that the slope of this terminal ray at 0 is 0. And we already know that this is a slope of 1. The reason I'm extending it all the way onto the line x equals 1 has to do with similar triangles. We've talked about this before. If I extend this ray up, in fact, I'll just go ahead and extend both of the rays. This one has to be root 3 because it's bigger than the other one, which is root 3 over 3. Root 3 over 3 is the same thing as a third of root 3, so it must be smaller. And then down here, this is -1, negative root 3 over 3, and then negative root 3. So this line at x equals 1 where those ray intersect sort of serves as a number line for how big the tangent slopes get. Okay, let's look at the compositions. So with the compositions, you just need to do the inside function first. Inverse cosine of -1/2 is asking me for an angle. So I'm starting on the inside here, right here, for an angle whose cosine is -1/2. So I want the cosine of theta to be -1/2. Cosine is the x-coordinate on the unit circle. I want the x-coordinate to be -1/2. Here's -1, so this would be -1/2. I'm going to draw an altitude, draw the hypotenuse, and there is my 30, 60, 90 triangle. But because this is 60 degrees here, I have to have 120 degrees as its supplemental angle. So this is really asking me for the sine of 120 degrees. You could also write 2 pi over 3. Now I go to that same angle and I find the sine. Well, I already know what the cosine was. The sine must be root 3 over 2 because it's a 30, 60, 90 triangle. Okay, sine of 7 pi over 4 is what I need to do in this problem first. So 7 pi over 4 is right here in the fourth quadrant. And the sine of 7 pi over 4, this is an isosceles right triangle. The sine value is -root 2 over 2. So this is asking for the inverse cosine of -root 2 over 2. Now inverse cosine is saying tell me an angle whose cosine is -root 2 over 2. That's actually going to take me into a different quadrant. I want the cosine to be -root 2 over 2, so I want to be over here, keeping in mind that we actually are not allowed to do anything down here for the inverse cosine. We're only allowed to do quadrants 1 and 2. So my correct answer here would be 3 pi over 4, or 135 degrees, but the problem specifically said to give answers in radians when possible. Okay, the last problem is asking for the cosecant of the inverse tangent of root 3 over 3. Starting on the inside, this is telling me an angle theta. I'm going to refer over to my handy diagram here, and I'm going to say, where is the tangent root 3 over 3? Well, right here, and I have to know that that angle is 30 degrees or pi over 6. So now I'm asking for the cosecant of the angle pi over 6. Cosecant is the reciprocal of sine, so really I'm asking you for 1 over the sine of pi over 6. Pi over 6 is that 30, 60, 90 triangle with the 30 degrees on the base, and the shorter side is 1/2. The longer side is root 3 over 2. Sine is corresponding to the y value, or the height, of 1/2. So this is asking me to do 1 divided by 1/2, or the reciprocal of 1/2, which is 2. Okay, the last problems here are basically just memorization. One thing that you can keep in mind is that the domains of the inverse functions are going to be the full ranges of the original function. So these are going to be the ranges of sine, cosine, etc. So I'm asking for the domain of inverse sine. I'm really asking you what was the range of sine. Same thing for cosine. And then the range of tangent was -infinity to infinity. So the ranges of the original functions become the domains of the inverses. Now over here, this is what you need to memorize. The range are going to be the angles that we had to restrict my original functions to in order to make them 1-to-1. And we did this in the notes, so go back and look at your notes for those pictures of why we chose those restrictions. So the range for the inverse sine function is -pi over 2 to pi over 2. And if we're thinking about that on the unit circle, that's talking about the quadrant 1 angles that are positive and the quadrant 4 angles that are negative. For cosine, it's 0 to pi. So that's quadrants 1 and 2, both positive angles. And then inverse tangent is very similar to inverse sine, except we do not actually allow ourselves to reach those endpoints because the tangent is undefined there. So you need to memorize those range restrictions. If you don't know these range restrictions, you're not going to be providing the right answers for these inverse trig functions, unless you just happen to get lucky and have it be in the first quadrant, because notice these all have first quadrant angles as outputs. But when it comes to any of the other functions, you have to know whether you're choosing, second quadrant for cosine versus third quadrant, which I don't have, or fourth versus third for sine. Okay, so that's the end of the video, and hopefully that helps you with your inverse functions.